Today in Copechi's Corner, we're going to solve equations by factoring. When we're going to solve a quadratic by factoring, the first thing we need to do is to check to make sure that the equation is set equal to 0, which in this case it is. Then we're going to look for greatest common factor, which in this problem there is none. I'm going to set up my two sets of binomials. I know the signs are the same. They're both a plus. Factors of 2 I know have to be 2x and x. And then over here I have factors of 2, which is going to be 2 times 1. So I need to work together to try to find something that gives me 5. So my 2 will go here, my 1 will go here. Now again, I can kind of check with my loops. It gives me a plus x. That gives me a plus 4x. When I add them together, I get 5x. So I know that I did that correctly. Now I'm going to set that equal to 0. 2x plus 1 is equal to 0, or x plus 2 is equal to 0. Because I know if I multiply this binomial times my second binomial and I get 0, that one of them has to be equal to 0. Bring my 1 to the other side, and I have 2x is equal to negative 1. Divide both sides by 2, and x is equal to negative 1/2. In my other binomial, all I have to do is isolate that x, and I have x is equal to negative 2. So my solutions are x is equal to negative 2, and x is equal to negative 1/2. Now in number 2, we don't have our equation set equal to 0, so that's the first thing I need to do. I notice that my leading coefficient is positive. I have a positive 20, which is what I want. So I'm going to leave that on that side. I'm going to bring this 15 to the other side. And I have 20x squared plus 5x minus 15 is equal to 0. Now I'm going to look for my greatest common factor, which is 5. So I'm going to factor out the 5, and I'm left with 4x squared plus x minus 3 is equal to 0. So now I'm going to factor my trinomial. Now this time I know that my signs are different. I have a plus and a minus, so I'm going to wait before I put them where I need them. I know that factors of 3 are 3 and 1, so I'm going to put that there. I know that for sure. Factors of 4, I'm going to have 4 and 1 or 2 and 2. So you need to come up with a combination with 3 that when I subtract, I end up with 1. And that combination will be 4 and 1. So my 4 goes here, and my 1 goes there. Again, my inside loop gives me 3x, my outside loop gives me 4x. Now because this is a plus, I need my higher combination, which is 4, to be a plus, and my 3 to be a negative 3. So my plus will go here, and my minus will go here. So when this is factored, I have 5 times the quantity of 4x minus 3 times the quantity of x plus 1, and that's equal to 0. Now I have to solve. At this point, if I look, I have two x's, one here and one here. So it tells me I'll have two solutions. I can't set this 5 equal to 0 because 5 isn't equal to 0. 5 is equal to 5. So I'm just going to leave that there. So I have 4x minus 3 is equal to 0, and x plus 1 is equal to 0. Bring my 3 to the other side, divide by 4, and I have x is equal to positive 3/4, and x is equal to negative 1. So they are my solutions to my equation. In number 3, I already have my equation set equal to 0, so I just have to look for my greatest common factor, which in this case is 2x. So I'm going to factor out a 2x, and I'm left with 3x squared minus 7x plus 2 is equal to 0. I'll rewrite my 2x, set up my parentheses. I know my signs are the same. This time they're both a negative. I know that factors of 3 are only 3 and 1, so I'll put my 3x here and my x there. Now, since the signs are the same, I'm looking for a combination of 2 and 1, that when I add them together I get 7. So I'm going to put my 2 here and my 1 here. Now again, we've talked about this before. If you happen to put it in the wrong spot and you check it, just erase it and try another spot to see if the new location works. So this time, at this point, I have 3 x's. I have 1 there, 1 here, and 1 here. So in the end, I'm going to have 3 solutions. I'm going to set 2x equal to 0, 3x minus 1 equal to 0, and x minus 2 is equal to 0. So in this case, if I divide both sides by 2, x is equal to 0. Add 1 to the other side, and then I have x is equal to 1/3. And I add 2 to the other side, and x is equal to 2. So they are my 3 solutions to this equation. In our last problem for today, we notice that we are not set equal to 0. On this side of the equation, my right-hand side, I do have my highest power, which is 6. So my coefficient here is negative 6. I need my leading coefficient to be positive. So I'm going to bring this to the other side. And I will rewrite my trinomial. So I have 6c to the 6th plus 9c to the 5th minus 27c to the 4th is equal to 0. So now I'm set equal to 0, and my leading coefficient now, which is 6, is positive, so I'm all set. Now I'm going to look for a greatest common factor, which in this case is 3c to the 4th. So now I'm left with 2c squared plus 3c minus 9 is equal to 0. I'm going to rewrite my 3c to the 4th, set up my two binomials. My signs are going to be opposite because my second sign of that trinomial is negative, so I'm going to hold off on where I need to put them. Factors of 2, 2 and 1. Now I'm looking for factors of 9. Factors of 9, I'm either going to have 9 and 1 or 3 and 3. And because my signs are opposite, I'm looking for a combination that when I subtract, I get to 3. So that will be 3 and 3. I'm going to put the 3 here and the other 3 there. My loops will help me. I have 3c and I have 6c. Now I need to get to positive 3c, so I need my higher combination, which is positive 6c there, and then I need a negative there. This makes my positive here and my negative sign there. So when I factor this, this is what I'm left with. And at this point here, again, I have 3 c's, one here, one here, one here, so I'll have 3 answers. I'm going to set 3c to the 4th equal to 0, 2c minus 3 equal to 0, and c plus 3 is equal to 0. Now if I divide both sides by 3 here, I'm left with c to the 4th is equal to 0. So we haven't really done the 4th root, but I know if anything that I multiply by 4 times is going to give me 0. I know it has to be 0. Again, I'll solve for c, so add 3 to both sides, and I have 2c is equal to 3, so c is equal to 3 over 2. And my final solution, I'll just get c by itself. So c is equal to negative 3. So my solutions are c is equal to 0, c is equal to 3 over 2, and c is equal to negative 3.